Have you ever wanted to be invisible? Well, today I will show you how. As light moves from a medium of a lower refractive index, aka air, into one of a higher refractive index, aka glass, it will bend towards the normal. And this is the normal over here. But we also see some reflection. That's what bounces off the object and creates an image for us to see. However, when we have two objects of the same refractive index, it will pass through and no reflection will occur, and therefore an image is not created of it and does not appear. Now we have a beaker with a piece of glass in it. You can clearly see the piece of glass in it. But if I put glycerol in it, we have the piece of glass and the glycerol, and they both have around about the same refractive index. And when I do this, we will see that it will turn out invisible. And it will be invisible, and that's because there'd be the same refractive index. So how can this work in being invisible? Because how does that connect? Well, we saw that the same refractive index makes the object invisible. But what about the air? The refractive index is 1. So if we were a refractive index of 1, we will essentially be invisible. And so this is a really cool way about how light behaves, and there are other cool things that light does as well. So what we are seeing here is a more exaggerated drawing of what we saw before. As a white light moves from air into the prism, refraction occurs because the light slows down and bends towards the normal. And as it leaves the prism, it speeds up and bends away from the normal. Violet light slows down to a greater extent than the red light, and so changes direction by a greater amount. This separates the light into different colours, thus creating a rainbow. Okay, so when we have wave fronts coming up to a slit, and by the way, wave fronts are when we have a wave, and it is the crest. So each of these represents a crest. When it comes up to a slit, it will diffract, and this means they'll move outwards and form this sort of pattern. And we have these wave fronts move up to the two slits. And they once again do have complete diffraction. And there we have, looking at this center line, we have the wave fronts joining together and creating greater amplitude, which creates a bright spot. But it's spots such as, which ones? These ones. That one over there. We have a crestatrometer, which creates destructive interference, and a black spot will occur. And this creates a interference pattern.